Today we're going to be diving into double replacement reactions a little bit more. I figured, we've been doing so much work with all these equations and trying to figure out what the right compound formula is and all that stuff. I figured I'd actually show you a reaction. I mean, this is chemistry class after all. So on the screen you see two beakers, and each beaker has about 100 milliliters of water in it. You can't really see the water. You can kind of see it sloshing around there. Okay. Then I've got two ionic compounds. One is zinc chloride here up on top, and I've got lead nitrate here on the bottom. What's the state of these? These are in the solid state. Okay. I'm gonna put these into the aqueous state. I've got this kind of white powder in here, and if I kind of break it down and mix it up, it's gonna dissolve into the liquid, and it's gonna turn into the aqueous state, right? It dissolves into the liquid. It disappears, but it's not like it just disappears into thin air, right? It breaks up into its ions. I'll show you a little picture of that later. I'm going to do the same thing with, so here's the lead nitrate. Okay, I'm going to do the same thing with the zinc chloride. Okay, see if I can just a little bit, just a pinch. Okay, so I'm taking it from the solid state to the aqueous state. Now, before we go on, let's write down, try to write down a chemical equation for these here. So I'm gonna let's do this here. Okay, so this is what, jot this down in your notes. Okay, this is what I'm reacting. I've got lead nitrate, that's this guy right here, and I'm putting it together with zinc chloride, this guy right here. Okay, so let's see if we can predict the products. What are the products going to be? I'm just going to kind of draw my bridge here. So this metal is going to this non-metal, and then this metal is going to come over, get with that non-metal. Okay, and then you just kind of switch them. PbCl plus zinc nitrate. Now the thing is that you got to kind of pay attention to your charges. Lead has a +2 charge here because it's with two -1 nitrates, and zinc has a +2 charge. So if lead's +2 and zinc is +2 and chloride's -1 and nitrate's -1, you've got to do a little crisscross applesauce action. PbCl is going to be PbCl2 and then zinc nitrate. Now put parentheses, and don't put anything into those parentheses yet. Okay? Now, what would you say if I told you that this equation, this chemical equation on the board, it's actually not the correct way to write the chemical equation. It's actually a lie. Like everything in education, it's just a series of lies that we tell you to kind of push you through to the next level, and you get a little bit closer to the truth, and hopefully by grade 12 you're closest to the truth. But this chemical equation is not the correct way to write this, and I'll show you why. Okay, let's keep that. Let me show you what's going on here. Okay, so up here on the board, I've got a kind of simulation of what happens when you dissolve a ionic compound into water. Let's see what happens. I got my little salt shaker here. Let's shake, get some salt in there. What happens? It separates out. So in the chemical equation, we write them together like lead nitrate is stuck together. It's not actually stuck together. It's actually buzzing around in solution. Okay? Solution is just your water and your ions there. Okay? So if we go back to, let's go back to our equation. Let's modify it a little bit. Let's go ahead and break up the compounds into their ions. Okay, what I'm going to do is I'm just going to start breaking these up. So this is going to, so lead's going to go there, nitrate's going to go here. Right. This is after you dissolve it into solution. You've got ions. So this is what you actually have. You don't have compounds that are stuck together. Now you've just got a bunch of ions that are just kind of floating around and in solution. Okay? So let's go back to our reaction. What I'm going to do is I'm just going to add the solution of my lead and my nitrate ions to my solution of zinc and chloride, and let's see what happens here. I don't know if you can, kind of, yeah, it turns into kind of like a milky, okay? Now, I'll kind of hold it up. This is what it looks like here. Now, the fact that it's milk is actually a white solid. We call it a precipitate. I don't know if you've heard that word precipitate before. Precipitate just means solid. Okay? So, the question is, what's the identity of that solid? What's the identity of that solid? Is it PbCl2 or is it zinc nitrate? But for double replacement, there's actually rules. Okay? Certain salts containing certain ions are soluble, certain are insoluble. I'm just going to tell you right now that that white solid that you're seeing is lead chloride. So put a little S here. And then the zinc nitrate is aqueous. So what I'm saying here is that when you mix these two together, the lead hooks up with the chloride, turns into a solid, turns into a white precipitate. But the zinc and the nitrate, they're still just hanging out in solution. So here's how we're going to do this for our separated equation here. PbCl2 is still together. You don't do anything with that because that's solid. But zinc is still by its lonesome. Zinc is still aqueous, and nitrate is still aqueous. Now, this elongated form, this equation, this really long equation, is called a complete ionic equation. So, we've got a complete ionic equation. Now, here's the thing. You've got the nitrate and the zinc on the left. You've got nitrate and zinc on the right. Did anything happen to those ions? There was no chemistry that occurred. So, these have kind of a special name. These are called spectator ions. Nitrate and zinc. They're the ones that don't form the solid. And what you can do, I'll get to your question in a minute, Sarah. What you can do is just cross them out. because they don't do anything. They're just hanging out watching this reaction happen. They're spectator ions. Finally, I'm going to write down what's called my net ionic equation. And that is just the stuff that does the chemistry. Lead cation plus chloride anion is going to turn into lead chloride solid. And I'll go ahead and balance that. I'll put a 2 in there. So that is my net ionic equation. Those are the two ions that end up actually reacting in my double replacement reaction. The other ones are just hanging out. Okay. Okay. So from the regular chemical equation, you can get two equations. You get the complete ionic equation, that's the really long one, and the net ionic equation, which is the shorter one. Monica. Okay. So let's let's get back to Sarah's question. How did we know that this is going to be the solid? There we go. On page 344, you've got a table that looks like this. Let's see if I can. In water, meaning when you put that sodium chloride in there, it's going to break up and the ions are just going to kind of buzz around. Let me show you a salt. Let me show you a salt that is insoluble. Insoluble salt, even when you put it into water, most of it just is going to stay bonded together. It's still going to stay clumped together. Maybe a couple of ions are going to break off, but in general, it's all going to stay kind of stuck together. This is an example of an insoluble salt. Okay? Now, if you go back to your table, certain salts are soluble and certain salts are insoluble. And it gives you a list. Okay? Nitrate salts are pretty much always soluble. If you go back to our example of our reaction, guess what? Zinc nitrate, the one that we called that's still in the aqueous, is soluble. So it's not going to be a solid. All right? Okay, let's just do one more example here, and then I'll break you up into your Okay. So with any double replacement, just draw your bridge here. And that's going to help us predict the products. One of our products is going to be HNO3. We don't know the state of that one. One of our products is going to be AgCl. Okay? Make sure that the charges are going to line up here. +1, -1. Okay? Now, look at your table on page 344. See if you can predict which one of these products is going to be the solid and which one's going to be aqueous. So if you look under your table, it says nitrates are pretty much always soluble. So this one will be aqueous. And chlorides are soluble too, but except when they're with silver. Silver is an exception to the rule. So this is going to be the solid. Now, 33 wants the net ionic equation. Now, once you get good enough at these, you can just look and see, okay, you can kind of tell what your net ionic equation is going to be. I'm going to do the complete ionic equation just because I think it's easier to see it that way. I'm just going to break everything up, except for AgCl, because that's a solid, right? Now, the question in 33 is, which of these are the spectator ions? Which of these are the same? NO3 is the same, right? H plus is the same. Now we can go through and make our net ionic equation. Remember, this is our complete ionic equation. Our net ionic equation is going to look like this. Ag plus Cl minus goes to AgCl. Okay? Spectator ions are going to be H plus and NO3, and this is our net ionic equation.